Good morning. I picked a pretty provocative title. Last week I spent some time writing a paper about cross-cultural management, and one big part is communication. And I learned that the first part in any communication is getting attention. So there's multiple ways of getting attention, but I thought one way is just pick a provocative title. And it looks like it kind of works because a lot of people are joining this session, and actually I got the bigger room on this conference. So first success in this talk. This picture is Falcon 9 from SpaceX. Why did I pick this picture? I will talk about that a little bit later at the end of the talk, in fact. So before jumping into the topic, I quickly want to introduce myself. I currently work for Skype. I joined Skype about 1.5 years ago, 2014, and the stuff I'm talking about here is based on experience at Skype and my previous experience. I was heading until recently the test organization of Skype calling and media services. So everything about call setup and streaming media in audio and video. If it sucks in Skype, 50% of this can go to me. The other 50% is Jan Plasberg, who's sitting here in the first row, because he owned the other part of media testing. So beside heading the test org, I was also involved in helping Skype moving off peer-to-peer technology to a cloud-based microservices architecture. So that's how I spent my last year, basically. We launched first iterations of that new product or new architecture. If you're lucky or unlucky, you might be in one of those test flights that we have going on. And I also spent some time on trying to bring continuous delivery to Skype in the services world, but also in the product world. Before that, I worked for Nokia, or what is now has been rebranded a while back, to HERE. It's just a horrible word for a company, so it's hard to mention, but I always say Nokia Maps. So it's actually the mapping division of Nokia, the guys that built the apps on the Windows Phone, in case you're one of the few Windows Phone users. But also, HERE is building a mapping platform, which is providing a bunch of REST services, giving you mapping functionality. And that's the visual map, for example. It is routing, geocoding, traffic, and whatnot. And it's used by much more companies than just Nokia or HERE. It is used by external companies, like our first big customer was Yahoo. Then we had Bing Maps. We have Amazon Kindle, for example. If you use the navigation app on a Kindle, that's also powered by the same platform. To give you kind of an idea of the scale, it has a bunch of REST services, microservices. It is about 99.95 availability. And when I left the company, it was about 7,000 requests per second running on AWS. So before I left the company, we actually migrated this platform from an internal cloud to AWS. And before that, I worked for Accenture about 7 years on different enterprise projects, so large-scale software development projects, and customers like Deutsche Bahn. My first job was actually at Deutsche Bahn, trying to figure out, we were replacing an old X25 host-based ticketing system with a web-based technology, and my job was to figure out, if you have only 2 wires going into a train station where you sell tickets, how do you get TCP over that? The solution is VDSL, but this is a long time ago, so this was 2002, basically. That was my first job. So it is actually my last week at Skype. Actually, yesterday was my last day. I'm on vacation today and tomorrow. And on Monday, I'm joining Klarna. So, hey. So I thought, hey, let's give this talk so I can get to know everybody in engineering, because I'm heading a team of delivery leads in Yuval's group. So I'm trying to help deliver cross-team initiatives. I heard there's some issues, and I hope to bring in some knowledge about how can we scale Agile and how can we deliver better across teams. Has nothing to do with testing, but still I'm talking about testing here. So, good. Quick intro about the talk. So you are on the top, and there's lunch down there in about 40 minutes from now. And in between, I'm going to talk about what is testing in production, why would you do that, what's the motivation for doing it, and then how can you actually do it. So I'll give some concrete examples. Also some architectural diagrams. I'm not just showing pictures. And then some Q&A if some time is left. I might overrun. We'll see. Good, let's get started. So what is TIP? TIP is about real users. That means you're testing doesn't happen with some artificial test user, but you actually use the real users in the field that use your product for your testing. Sounds pretty risky. But the reason why you're doing this is you want to have the diversity that the real user has. If you're deploying a product in a global market and on different mobile applications or mobile platforms, you want to have that diversity. You can't build that in a lab, and I will talk about this a little bit later. If you're in the services world, you're talking about testing in a production environment. So if you run on AWS, your production environment, that's where you do your testing at the end of the day. It sounds pretty risky and hairy, but there's actually a reason for that, and I will talk about it. Usually, if you read about test and production, there's a few blogs out there. Most people refer to it in the services world, and that's where it's pretty easy. But actually, you can also use it to release your products, like your app, for example. And Skype or Microsoft in general is heavily betting on testing and production to release their products, just because of the scale and diversity of the consumers that are using these products. TIP is about risk mitigation, so it's not about being having the thrill of doing this open heart operation and testing in production. It's about mitigating risk, because you're not just flipping a switch and enable your product for all the users out there. So you get a set of methodologies that actually allow you to kind of test up front in a controlled way. If you do test in production, and some companies are moving more and more into that direction, you are changing the culture of testing in terms of moving away from a test-driven quality to a data-driven quality. What does it mean? The signal that you want to get if my product is good in terms of quality is not coming from your test anymore, but it's coming from huge amount of data that you're analyzing as you release your product. TIP is also a set of test levels. So if you think of your traditional test pyramid that Mark Cohn framed, and I think Martin Fowler also has a definition for that, the test pyramid is basically saying you should run a lot of tests on the lower levels and less tests on the upper levels, the higher levels like end-to-end, because they're fragile, they're expensive, they break all the time, and so on. So how does TIP fit into that picture, if you like these kind of methodology pictures? I would argue TIP is just another pyramid turned around and put on top. The difference is the traditional test pyramid talks about the number of tests. The pyramid, or the inverse pyramid of testing and production, is about data. So if you move up the chain, let's say you do a small test within your team, you build the client or you build the service and you use the service on your own. We call this dog food at Microsoft, or self-host. You get a little bit of data about the product quality. You get a small signal. As you move up, you extend that scope, and I will talk about this later on. And if you're in production, you get the full-blown data that you want to know, is my product quality-wise good or not? And the data is expanding, so that's why I draw this pyramid a little bit the other way around. There's one guy from Microsoft, his name is Seth Elliott, and he wrote a lot about testing and production. He turns this thing by 90 degrees, and then it's called the dog bone. Maybe it's more visual and more sticky. But just to give you a visual picture of how this fits together, or the traditional test pyramid. So what's the motivation? Why would I do test in production? One reason is speed. This is the Skaget Bridge. Jan knows this example. I use this all the time. So this bridge collapsed sometimes in 2013, and I was working at this mapping platform company called HERE. And as a map platform provider, you want to always kind of reflect reality. So your map should show what's actually happening on the road. So if the bridge collapses, ideally you would give an update on the map, you would change the visual, you would say, hey, there's no bridge anymore. And if you plan a route from A to B, you can't drive over the bridge. The routing service would tell you there's no route anymore. Back then, we had a pretty lengthy upfront testing process. So we did all kinds of perf testing, like 3 days of extensive perf testing and whatnot. And the whole process actually of updating a map was very lengthy. I don't tell you how long, but it took pretty long. The problem was, in the meantime, somebody fixed the bridge. So before we could get a fix out, they actually fixed the real world. So if we would have deployed the fix, we would have deployed another fix to make it reverse it again. So it didn't make sense. We decided at the end of the day, just don't deploy the fix, wait for the contractors to fix the bridge. But it kind of caused a good discussion with the management team saying, what the fuck, why does it take so long? And it caused the test team to say, do we actually need 3 days of load testing before we can release any kind of data to the production environment? So we changed the whole test strategy, actually. And this little bridge actually caused this good discussion, which I'm happy about, that it collapsed. Back then, I was actually heading this test team, so you can blame me for that. But the point here is, it's an extreme example because it took days to get a fix out. The point here is that if you look at companies like I worked with Flickr, they deploy 20 times a day. If you deploy 20 times a day, and that's work hours, not at night, you have 8 hours time frame, you don't do a 6-hour load testing. They just do this in production. If it goes south or if shit hits the fan, they just roll back or roll forward. So they rely heavily on other mechanisms to do perf testing. Another motivator might be large-scale services. So if you run at a massive scale, you can not test everything in a test environment. You can always argue, okay, my production environment is 100,000 servers, maybe at Google. Let's just take 1,000 servers and let's do our load testing. That works to get an idea. But if you want to cover things like load balancers network, or if you work with content delivery networks, it's kind of impossible to test those things in a test environment. You will never reach the saturation of a load balancer or a certain switch, for example, in a test environment. So inherently, you will have to do that in production. There's no other way around it at a certain scale. Distributed systems or microservices, super hype at the moment. I think every company does it. This picture is actually from Adrian Cockcroft. He presented that at one of the conferences. And this circle is a diagram of Twitter's services dependencies. There's another one from Netflix that's even more messier. Point is, it's pretty complex. I don't think in Skype anybody ever draws such a diagram. I don't think anybody can, because probably nobody knows how many services we exactly have. My guess is 150 in total. In my area, it was around 30, I think, in total, but there's tons of other services out there. And the point is, nobody knows how this all works together, and that's okay. That's the whole point of microservices, in fact, because that's how you scale your organization. That's how you scale your architecture. The problem is, how do you test this? So in the traditional value stream, you have teams testing your whatever, their service. Let's say they develop one service, they test the service on a functional level, maybe they do some perf testing, and then if you have a bunch of services, you might integrate them. So you have some kind of system integration testing going on. That works for a number of services. You also push them out together, usually, on a release train or whatever you do. That works for a number of services, but if you talk about 150 services, you can't coordinate that. It's impossible. Also, the dealing with test environments, then, how do these services test against each other? It's kind of impossible to coordinate that. So if you talk about large-scale services and lots of services, the picture that microservices actually want you to do is being independent, having autonomous teams, and you're pushing into production independently, each team independently. There is no such thing as a one big integration test to make sure that everything works together before it goes out. It's just impossible. At Skype, we have like 4 or 5 different locations. It would be impossible to coordinate these different time zones to go together as a release train. That's an extreme picture, though. So you might build domains, for example, where you say, okay, test these services together and they go together out, but not the whole set of services. It's impossible. So how do you do integration testing then? There's one option, I don't know if you guys are using this, but it's called CDCs, consumer-driven contracts. So you're basically making sure that you run a bunch of tests from your consumers before you release anything. So that could be your upfront testing to make sure you don't break any dependencies. But that also kind of implies that you know who's consuming you. In such an environment, you probably don't know anymore who is actually your consumer. So you end up testing in production your integration test at the end of the day. And I will talk about how this could look like. Running in the cloud. Werner Vogels, he once said, everything can fail all the time. And in an AWS environment or Azure, that's pretty much true. Azure is very stable, and Amazon as well. But there's also lots of outages. Regions go down, services of Amazon goes down, instances can fail all the time, they can reboot. You might have a reboot of 1,000 instances because somebody installed a patch. So all these things can happen. And you basically have to build your software and test your software, because we are testers, to make sure that you survive these failures. You can do this in a test environment, or you can do this Netflix-like in production, basically saying, hey, I'm going to shoot these different things randomly at any point in time, and you better make sure that your stuff runs and survives these failures. And I will talk about this also later on, how this could look like. Diversity. This picture is the Android fragmentation, the hardware fragmentation. There's 24,000 different Android hardware devices out there in 2015. That's 28% more than last year. So if you're relying heavily on, for example, mobile platforms and hardware, for example, Skype has sometimes a tight relationship to hardware because of offloading of rendering and so on, then that's a challenge. How do you deal with all that? This is hardware. So you could argue, okay, I don't have to test every device, that's true. But if you look at another picture, how many screen sizes, for example, does this imply? How many different OS versions are out there? It's pretty crazy. Building a lab for all of this is impossible. Nobody has the money to do that, not even Microsoft. So we don't test all combinations. We have a high-end and a low-end device, and maybe something in the middle, but we don't test all combinations. And you're missing something. So you have to rely on testing in production and certain data to tell you if you screwed up one of these 24,000 devices. And it can happen, because there might be such a dependency on hardware, the screen size, or whatever. The other element that is important is not just the devices, but also the environment that these devices are living in. So take, for example, the network. I think it's Skype's biggest enemy. If you have a sucky network and it's your Wi-Fi hotspot, probably at home, that is so sucky, it creates a really bad video and audio experience, and it's not our fault, but that's how it is. That's reality. So we can't blame it on the end user. We had discussions about showing pop-ups, saying, hey, your Wi-Fi sucks. But you know what? I don't care, because maybe Hangouts works better in this scenario. So you have to also account for the environment. How does a network limit or impact my product? Most companies actually don't do that. Facebook just also started recently looking at how does the Facebook app work in an edge environment, which is the dominant environment in India, for example. So you want to take that into account. We do some network simulation in Skype, but it's also very limited. You can't simulate all the possible environments that you have out there. Yeah, you have crazy users or inventive users. Always remembers me of my mother calling on the weekend, asking me why the heck is this and this not working on her Mac. Yeah, because she does crazy things with it that I would never imagine. So if you're writing your test, you're always writing a test with a certain mindset saying, okay, this is how the scenario should look like, because that's how we think the user will use it. Guess what? If you put it out to the user, he will use it in a very different way, and you will be surprised. If you run REST services, they're pretty open, right, to everything. So we had a case in HERE where people started planning routes 6,000 miles long. I would never imagine somebody is doing that at a massive scale. Maybe one dude that is driving from whatever, South America to Alaska is doing that once in a while, but not at a massive scale. And guess what? The customer didn't care. He said, well, your service allows it, so why is it so slow, and why is it killing your service? So we never imagined this happening in our environment, and REST services are a good example of misusing. Your consumer might just interpret your API wrong or whatever, and he passes you some parameters, and your service might crash. So you have to monitor that in production, because you can't anticipate what the user is doing. So lots of whys. Let's think about the how. You want to limit the impact. That's what I think TIP is all about. You want to make sure you don't screw up and you impact the end user. Even though it sounds like testing production means I'm risking I'm burdening the end user of testing. No, it's not. It's about limiting the impact. And there's tons of buzzwords or methods or buzzwords out there. And I will talk about a few. You guys probably doing services, you probably know all about that, so I will do this quickly. But canary, I think that's a term probably framed by Twitter. But it basically means if you do services, you have a bunch of servers, let's say 1,000 servers, you take one out, you upgrade your service, you put the server back, and you make sure that this little canary node doesn't go ballistic. And if it goes well, then you scale out your deployment. The other option is blue-green. So you have two different pools. One is your production pool, the other one is the next version. You upgrade on that next version, you flip the switch at some point, and then the traffic goes to the new pool, and you destroy the old one, for example. Flighting, I think that's probably a Microsoft term. I'm not sure if you guys are familiar with that. It basically means you enable a certain percentage of traffic, and this can be certain percentage of users or certain regions or whatever you want to the new service, to the new version that you're trying to deploy. So this way, you're also limiting the impact in terms of how many users actually served with that new service or product or feature. Forking, I think it's also called dark traffic. It basically means you have some kind of front door, and it allows you to send requests to your production service, and at the same time, it's duplicating that request and sending it to a test environment or a blue-green deployment, but you throw away the response, so you don't really serve the end user with that new version. It's perfect for perf testing, so we use that a lot in here to get away from all these load testing tools and whatever. We just set this front door, we enabled it, and it just streamed us traffic to the service, and it allowed us to analyze how is this current traffic pattern in production impacting our service, how are these requests that are coming in impacting the performance. That's a really nice thing. The only problem is it mainly only works with stateless services. So if you have a client that expects the state, because you throw away the response, that doesn't really work that well. Synthetics, I think also a Microsoft term. It basically means you run your parts or the whole functional or end-to-end integration test suite in production. And I will show you how this could look like in a minute. A/B testing, that's figuring out is my feature actually useful for the end user or not. So you get a lot of feedback about is this new feature useful or not. Data, so the whole test in production is about data, and I have a few slides about that. It's about gathering information if my service is healthy, if my product is healthy throughout the process. And dog fooding. Dog fooding, eat your own dog food. So you use the application on different scales, team size, org size, whatever. I'll show you some examples. So this is not complete. This is just a small overview. But think of these buzzwords and how you can apply those. So let's run through an example. So let's say you have a service and you have a consumer that loves you, or another service that is consuming your service. So you have like different services talking to each other, and you have your version 0 running in production. And let's say it's on Amazon. It's in an auto-scaling group. And you want to deploy your new service. And I think ideally you do this in a fresh install. So in Amazon, you might bake an AMI and you bring up new instances and you bring this up in your new auto-scaling group. Fresh install because you don't want to deal with old configurations, upgrades. I think it's called snowflake servers. You want to avoid that. So if you're running in the cloud, use the opportunity to bring this up freshly. Then you expose the service through some DNS, and you might have a test user that is going to connect to this thing and trying to figure out, does it actually work? And there's different levels of validation that you could do. First of all, you want to know the bits that I'm deployed here. Is that actually the bits that I wanted to deploy? Is it configured as the right environment? Is this actually the production instance now? Does it, for example, point to the other production services? Or does it point to some test instance of another service that I'm depending on? That would be probably a nightmare. Then you want to test the service itself, so some kind of health check. You want to check out, okay, I'm sending a request, do I get the response back that I wanted to get? And then, and then you run your synthetics, you run your integration and end-to-end test suite against that service. You want to basically do your integration testing in production. So if you run a certain test suite, either for the service, but also maybe including the dependencies, you get a good idea if this service survives with all the other services around it and all the dependencies in this production environment, but in a controlled way. You haven't touched any end consumer yet. You do this in a synthetic way. So if you're done with that, you can basically say, okay, let's put this thing into rotation. So let's enable certain traffic, and you might do the forking if you have a stateless service, enable certain percentage of traffic, and throw away the response. Ideally, you have some sort of we call this the experimentation service, but you have a central service that lets you control your consumers to point to this new service with a certain percentage. So this can be simply percentage of traffic in terms of the requests that are going there, and you might start with 0.1%, or you decide to say, okay, only a certain user group, and this could be your team or the whole company, or you decide a certain region, North America or whatever. So you can configure this thing and tell the consumer, hey, there's a new version of this service, please redirect X% of the traffic. The other option is if you're more in the stateful world, you flight some of the traffic. So you really serving now end consumers with a certain percent of traffic. But it's better to screw up 0%, 1% of 300 million users than 300 million at once. So the point here is that you you're flying 0.1, and then you move up 1%, 5%, 100%, and if you're on 100%, you're basically done with your deployment. And then you cut the wire to the old service. You might want to keep the old service for a while, because the rollback in this scenario is simply switching the DNS or telling this configuration service, hey, something is wrong. We figured this out after a few hours, whatever, memory leak or something. Hey, go back to the old service, and you can easily switch this thing back. And then you might just destroy this old autoscaling group in AWS, because you don't need it anymore. While you're doing all that, you have to look at the data. So you have to really good insight, and you have to build this into the product to tell you, yes, I'm healthy, or no, something went wrong. And this has to be built in right from the beginning. And you need all the different tools they have, whatever, Nagios, Splunk, Hadoop, whatever you do. Skype has its own data platform at massive scale, which collects data from mobile devices, desktops, but also from services. And you have to have lots of dashboards and whatnot. I will talk about this. And ideally, this is a very repeatable process. I would be surprised if this is changing every time you do a deployment. And if it's repeatable, as Dan North said earlier, it should be fully automatable. And I think this is actually very important. If you want to do test in production, you don't want to do this manually. You don't want to go in and SSH to some machines or whatever and start messing around with configurations. And you can fully automate this process. Here's an example what we did at HERE. So you have your AWS API, and this gives you the whole access to all the services of Amazon, so you can programmatically talk to it. Then you need some sort of infrastructure code on top of that. So you want to, for example, bake an AMI to upload it to Amazon, and you might use Puppet for that. But you also want to take that AMI and then scale it out. So you put it in an autoscaling group and say, hey, of this AMI, I need 20 instances in this new autoscaling group. And we used actually Asgard for that. That's also a Netflix tool, if you guys are familiar with that. They have tons of tools on their GitHub page. Asgard is one of them that is pretty nice. So if you do an AMI-based approach, I can really recommend this one. If you do Docker or something, more of the new stuff, then that probably doesn't fly. Then we called this thing glue code because we couldn't come up with a good name. We didn't have cool names. You need some sort of deployment orchestration. So Asgard does some of the job. You need to talk to the Amazon APIs. So for example, you bring up the autoscaling group, you take the AMI, then you need to enable Route 53, blah, blah, blah. You need to do all that. You need to orchestrate that. But you also want to have a certain understanding of the state. So if I do my deployment, and let's say the Route 53 entry didn't happen in North America, then you might need to roll back. And you need to keep that state. But you also want to have a certain retry logic. So you want to be able to say, okay, this API call failed on Amazon, and this happens, just retry it a few times. So your global deployment doesn't screw up because one API call failed on Amazon. And we did that in Ruby. And then on top of that, you could model the process, the previous PowerPoint, nicely in your Go or CD pipeline. So you can basically define in your CI, CD tool, whatever you use, Jenkins, Go, and define those as pipeline steps and say, press the button, and then it does the deployment. Maybe first Europe, then North America. It does maybe first one AZ, then the other AZ. And it's a very repeatable process, and therefore you can nicely model that. So that's an idea how such an automation stack could look like. Before I talked about the testing in production in terms of you do your integration testing, you run your synthetics and whatnot. What is missing is the failure testing. As I said earlier, everything can fail in a cloud environment. So you need to simulate failure on a regular basis because everything can fail. I think it has the same importance than any functional regression testing. Because if stuff breaks in AWS, and it does, or in Azure, you want to be prepared for that. And you don't want to figure that out on the week before Christmas when everybody does online shopping. You want to do this on a daily basis. And you want to do this regular, but not too regular. So don't schedule a cron job every midnight to do the failure injection testing. That probably doesn't happen, it's probably not very useful because you probably have low traffic at this point in time. The other question is also in which environment are you doing this? Are you setting up a test environment and then it's all nice and fluffy and you just do your failure injection, yeah, and stuff fails and I open a bug and maybe the bug gets assigned as a P3 to the dev team and then they might fix it in 3 months or not. Because it's not that important, right? How Netflix does it, they just do it in production. They just say, hey, look, if you deploy a service there, we're going to shoot this service. Maybe you take down the AZ, and then you better make sure that this thing still works. So you have a totally different attitude in terms of creating technical debt. There's no technical debt in that sense, because you're just deploying a service right from day one, in the right way. Otherwise, it won't survive in production. And you're better not on call then, because they probably wake you up a lot of times. So I guess for starters, you do it in a test environment. You could argue it like that, but you could also argue and say, hey, let's do that in production right from the beginning. And there's lots of tools out there. So if you run on AWS, Netflix has a huge collection of those. We did something on our own in Skype, so we created actually a framework to do specification by example. And we glued a few tools together using SpecFlow on top, some helper classes, and then we connected our perf testing tools to generate some synthetic load if we didn't have enough load, do some validation service, and then a service for injecting actually failures, something like Chaos Monkey. And this is how a scenario could look like. So a scenario would be, okay, I want to restart a media service while a certain conference call is going on in Skype or in Lync. And you could specify, okay, I want to have a small conference call, like 5 people, or I want to have 100 people in this call, and what happens if I restart my instance? So that's kind of a BDD approach to failure injection testing. I talked a lot about data. So the second how part is moving to a data-driven quality. Basically means in your value stream, you have the developer and the happy customer on the other scale. Usually rely on testing, lots of testing, hopefully in the early stages. This is more or less a reflection of the test pyramid again, what I showed earlier. So you have lots of tests running on the early stages, and then the number of tests are going down. At the same time, if you rely on test in production, your metrics go up. You get much more data inside as soon as you move into production. And this is kind of ramping up. So this is conceptually how this could look like. Some companies try to move that orange curve to the left side. So they try to get rid of some of the integration end-to-end testing and rely more on data in production to figure out if the product, or to get a good signal on the quality of the product. Here's an example how this might look like. It's actually from Skype, or slightly adapted. So you have your big upfront testing, integration unit, whatnot, and the data you get is usually your build stats, your test results, your CI metrics, like flaky tests and all these kind of things, and maybe some NFRs, like maybe you have some battery testing on a mobile phone going on and so on. And then you might do some self-hosting. We call this self-hosting, which basically means parts of the organization are trying their own dog food. So maybe a team is building a special version of the client, and they're testing it on a daily basis. It gets automatically pushed, and it's happening on a daily basis in case we have a build that is surviving our CD pipeline. And you're using it for your work, but also for your private life. So you take it home and whatnot, and you call your parents or your family over this version. And then you report bugs. But you also get a good signal on crashes, for example, because you're already using probably more platforms and devices than you have in your lab. But still, it's very limited. The next thing would be dog fooding. So you might release this app to the whole company or the whole division. In our case, that would be Skype, 2,500 people roughly. And they start using this thing on a day-to-day basis. And they report a lot of bugs back because they're really using the product. Still, there's a bias because everybody working at Skype is using the product in a certain way. We have like hundreds of contacts and whatnot, lots of chats going on and so on. Other people don't have that. So there's a limit. Also in terms of the platforms. You know, Microsoft is not a Mac company, so you mostly have Microsoft Windows phones and desktops for testing. So once you decide, okay, you might do a silent launch. So you're pushing certain builds out to Skype.com or to the App Store, but you don't tell anybody. So only the poor person that accidentally downloads from that source gets that build. It's a very limited amount of people. But still much, much better than dog food because it's reality, it's real users. You're watching that silent launch pretty closely for a few days and you see, okay, what's happening? And then you might recommend that build. Recommend build means you get the pop-up saying, hey, there's a new version you want to update. And that's basically the release. The data you get there is much, much more in terms of perceived quality. NPS scores, for example, or Skype has this call rating thingy, the star thing where you can say this call sucked or not. So that's really where the user tells you this is a good build or this is not a good build. You also can watch the forums, Twitter, and whatnot, people bitching about the product or excited about the product. You can call the support hotline and see how many tickets you got and so on. And then you might So you have to build out to all the users, but you might not have enabled the features that you as a team developed. So you might want to flight that specific feature on that build that everybody has now. And there is this configuration service again, very handy. So you can basically say, okay, 1% of these users that are on these new builds or on a certain amount of builds, please go and enable this, and then they're going to use the new feature and get enabled. And they give you feedback. If it goes bad, then you just turn it back. So we had a case where we released a new Skype version, and one of the unit tests wasn't well written, and we basically crashed on every XP platform because for some reason we didn't test on XP anymore. We thought it's dead, but it's actually not. There's a lot of people using it. So this gave us the capability to just roll this thing back pretty much immediately over the weekend. What you get out of this is tons of telemetry. This is all very fuzzy intentionally because I can't show you the data. I would be embarrassed. No, I'm just kidding. There's tons of data out there and tons of dashboard. In a company like Skype or Microsoft, everybody's building his own dashboards. There's a certain challenge with that. What's the data that you're actually looking at and you're using to drive your company and your decisions? It's good to have a shared objective, I think. If you say, for example, NPS score is something we are all kind of striving to achieve a good value. You might also want to split this into tiers. So you maybe have an NPS score on the top, which is very subjective, and then you break this down into different layers to go down maybe to a service availability. And then you can assign those layers to different teams and different accountability and ownership. But you definitely have to embrace kind of a data-driven culture. So one thing, for example, is have data stand-ups or daily stand-ups looking at those dashboards and saying, hey, what happened last night? What happened yesterday? Is our product still good or not? Did something happen with our service or our app? And there's an example of how it doesn't work. So there's this one metric. I don't tell you which metric it is, but it's very different values. It is the same metric, but one is saying 31, the other one is saying 18. What do you do now? Do you build a task force? Let's say the 31 is bad. Do you build a task force and rally a team of 10 people around it? The reason why it's so different is it's coming from different data sources. It has different definitions. Take Skype as an example again. If you start a video call and you're switching off video in the middle of the call because the quality is so bad, is that a video or an audio call? We had lengthy discussions about that. So how do you classify these things? So defining the metrics and that everybody knows what is this metric about is super important. Otherwise, you might really rally a team of 10 people for 2 weeks about this metric to figure out, oh, it's actually the same thing. It's just different definitions of the metric. And that's pretty expensive then. So metrics is a challenge. I call this the metrics forest or dashboard forest. If you don't consolidate on this, you're getting pretty overwhelmed with all the data. And what happens usually if you're overwhelmed, you just blend it out and you don't react on it anymore. So you have to be very consolidated, agree on the metrics that are driving the organization, agree on the definition, and understand what it means, but also have a process. What if this metric goes ballistic? Do you have a team in place that is looking at it and then building a virtual team, a task force, or whatever? But there's also other challenges to summarize it. So this is, again, the same rocket, Falcon 9, that exploded. So maybe, very likely, if you're in this business, you're probably not relying too much on testing and production. And I think this also applies to the IT. So you have to really look closely what methods do I choose to do testing. Klarna is a finance company. You don't want to lose money. If you think of New York Stock Exchange, you probably don't flight 1% because that probably means millions that you might lose. But maybe it's acceptable. If you're maybe in a business where you only sell stuff for like a few cents, maybe that's okay. Take advertisement, for example. If you have a Bing homepage and the ads are not served anymore, yeah, whatever. Microsoft might lose a few dollars, but it's worth compared to the investment in any kind of lab environment. So that's a trade-off you have to make. It's a return on investment question. How much do I test up front and how much can I move into production? And you want to maximize that, but you have to figure out what's the price that I pay for that, and it doesn't work everywhere. So it can be pretty costly, right? If you screw up, if you test your software of the Falcon 9 once you launch the rocket, it's probably pretty expensive. Elon Musk might have the cash for that, but I'm actually wondering if he does test in production because he screwed up quite a few times lately. The feedback loop can be pretty long. In a services world, if you have all this nice deployment automation, you get pretty fast feedback from production. But if you release an app and you rely on your end consumer to tell you if you have a good product, it can take weeks or months. If you then figure out an issue, it's like going back in time 2, 3, 4 weeks or maybe months and figure out what was the commit that actually caused this issue now in production. So you cannot just shift into test in production. You have to have upfront testing to give you quick feedback. Otherwise, you will always have to go back in time for a very long time, at least on a devices world. Data acquisition and size. So you're collecting lots of telemetry about the product. MPS is simple, but in Skype, we analyze the different video calls, audio calls, and we take snapshots of what's going on in this call, what's the current screen resolution, how does it adapt, blah, blah, blah. That's a lot of data. Now, if you're in a mobile environment, this data is competing with production data. So let's say I have a video call going on, and I'm collecting hundreds of kilobits at the same time and stream this over the same channel. It's actually screwing up my video. So how do you prioritize that? You could say, yeah, then just deprioritize it. But now you're in a low bandwidth condition. So in India, you might have only an edge network. That means you always throw away that traffic. So it actually happened that we saw that our call performance or audio-video performance increased, but that's because we throw away the data from the bad calls that happen in these bad networks. So you get quite a bias if you don't handle the data correctly. In the services world, it's a bit easier, but there you have the problem of scale. So you need a pretty scalable data platform to collect all this data. Dog fooding. Sounds great, using our own product, but has some challenges. First challenge is getting enough users to sign up for a dog food. It's pretty challenging. Also to then report bugs, you have to make that very easy. If I have to go into some tool and enter some stuff, people don't do it. There's lots of companies out there that allows you to just check the phone, for example, send the bug report, so that's pretty handy. You also don't have the diversity that you want to have in dog food because you're always biased, as I said earlier. How to use the application, which environment, which platforms are using, and so on. Until recently, Skype didn't have many iOS and Android devices. Most employees had a Windows phone. But you also might have competing dog foods. So every team is saying, yeah, we want to dog food this feature, and then you end up with 5 different dog food programs. So you're kind of peanut buttering the organization and swamming them with all these different dog foods, and you have to decide, okay, which one do I sign up for? So there's some challenges with dog fooding. And with that, I thank you for listening. I hope it was useful.